objective of this webinar demo today is to present you the video 360 use case integration and experimentation in the French site facility in FAGIV. So before starting, I would like to thank all my colleagues and all the person having participating to this webinar demo and having supporting us during this integration. That was not so easy during this special period we spent the last month. So let's start now with the agenda of the webinar. So first of all, I will give the floor to Mauro Boldi, who is in charge of with the project manager of FAGIV. And Mauro will briefly introduce FAGIV. Then I will give you some inputs of the vertical, so of the 360 video use case with the use case owner point of view. So I think it's important to answer to some questions before experimenting the different verticals. Then I will present you the French site facility architecture design, and especially I will focus on the design of the experiment that we have implemented in our specific demo. Then I will let Sofiane explain us how we manage the infrastructure in French, the network infrastructure, especially by presenting the tools that we put in place for the connectivity between the different sites and to have the availability of the network infrastructure. Then Anne will explain us more in detail the use case and in a technical point. Especially, she will present us how the metrics, the KPI metric of the vertical are measured and are collected for the monitoring of the KPI. Then my Polish colleague will present us and introduce us ONAP, because ONAP is an orchestrator that we use in the French site facility, and the objective is to present us ONAP and also to deploy automatically one specific VNF, virtual network function, at the core level, core network level. Then Eliane will explain us how the vertical, how the use case has been onboarding at the portal level, and how is its execution, and how we can monitor at the portal level the different KPIs that we expect to collect and to analyze. And then I will present a very short demo, video, sorry, of the experiment. Explaining you more in details the setup and the KPIs that we can also collect at the site, and then I will conclude. So first, I will let Mauro give us some words about 5G project in general.
Thanks, Rodolphe, and welcome to everybody to this webinar from the project 5G. As Rodolphe is explaining, this is a webinar on the French demo facility. You know, the 5G project is based on 4 different facilities, one in Spain, one in France, one in Italy, and one in Greece. Many of you could have seen the webinar on the Greek facility this Tuesday, and we are also preparing similar events for the other sites in the next months. In particular, today you will see then the French activities explained, as Rodolphe was saying. It is quite an interesting 1 hour and a half for this webinar. Also, in the view of the interconnection of 5G with the ICT-19 projects, that are these projects working on specific use cases. Some of them are those that will be also implemented in the French facility. So thanks to all for joining today. I hope you will enjoy this webinar, and I will give back the control to Rodolphe and to the other colleagues to present to you this very interesting agenda.
microphone, Rodolphe.
Yes, sorry. Let's move now to the second part of this webinar. So, and let's focus on the video 360 use case, especially from the use case owner view. So the use case to be validated today is 360 video streaming, aiming at immersing users in the virtual reality scene. So as example, we will take the virtual visit of a very beautiful city in Brittany, Saint-Malo. But we can also use some different content like visit of museum, and also we can also imagine a live retransmission from recorded content, where one camera could be put on and we can see the scene distantly. So the way to validate this use case is first of all, the objective is to deploy the server remotely. So for instance, to integrate the video server in different locations of in the cloud, for instance, and to be able to see the virtual visit through virtual reality glasses. Our objective also is to deploy the 4G and 5G core and WAN network where the scene is hosted automatically. So this is also the objective of this demo, is to show how we can deploy some specific components in terms of infrastructure at different sites. And we will see how we can do that with ONAP especially. And the business motivation for operating this use case is, first of all, to identify the main service KPI that directly impacts the 360 video service. So this will be explained by Anne, especially. So in order to see what are the main important KPI at the service level that we have to analyze and to monitor for having a good quality of services of the use case. Also, our motivation is to analyze the impact of the video server location in the deployment. And of course, to analyze the benefit of 5G compared to 4G. So the objective is to see what are the main benefits that we can collect from 5G for this kind of use case. And as you know, now we don't have any 5G chipset integrated in the devices. So especially for the virtual reality glasses. So the objective also is to promote this kind of services and to push the equipment provider to integrate directly some chipset in the handset to have a wireless infrastructure, end-to-end wireless infrastructure. Okay, so in 5G Eve, we propose a vertical checklist by answering to the, I will say, the basic question of the why, the what, how, where, when, how, who. So this is a basic question that it is important to answer in order to qualify and to design the experiment. So as you know, we have the verticals owner, and the objective is to deploy these verticals in the specific environment. And the objective is to know more about the needs of the verticals for a good integration inside the SAP facility. So we make the exercise to answer to this question for the video 360 use case. So I don't go into details of each answer that we have for this video 360 use case, but for instance, about the why. For us, again, it is important to validate the main video service KPI and to map them to the network infrastructure metric by using 4G or 5G solution. And also, if I take the where, so we have selected in our use case a French site, but we'll see and we'll explain that the French site is a cluster of sites, and it should be that should provide different network infrastructure. So we'll see just after. So now let's focus on the French site facility architecture design. So just to have a brief overview of the French site facility. So the French site facility is represented by the yellow box the yellow box, because the franchise is composed of 4 different sites. So we have the entry point of the French infrastructure that is located in Châtillon in orange, Châtillon close to Paris. And Orange is in charge of providing the network infrastructure and the connectivity with the other side. Also, as already mentioned, so we are using ONAP for our local orchestrator, and the objective is that the cluster, the ONAP orchestration, is located in Châtillon too, where we can also find the VPN connection with the other side. So we have the other French site composed with Bicom in Brittany, Eurecom in Sophia Antipolis, Nokia Paris-Saclay, close to Paris, as I mentioned. And we have also the support of our Polish colleague that provide inside the French facilities the ONAP orchestration and the support of that. The main the particularity of the French site is that it is mainly based on open source. So I mentioned ONAP, but also for we are using open air interface, especially for the core and RAN network, and especially for the Bicom and the Eurecom site. Nokia is also using open interface in one of its pillars, but also Nokia is using their own 5G equipment in order to promote them. So this is for the French site composition, but at the northbound of the ONAP, we have the direct link to the interworking layer. So the interworking layer in 5G Eve is located in Turin, in TIM, and the objective of this interworking layer is to first manage the multi-orchestrator part. As we will explain in 5G Eve, we are using different orchestrators. And also the interworking layer is in charge of managing the connection with the other site facilities, so the Spanish site, the Greek site, and also the Italian one. And also to be able to, and is directly connected to the 5G portal that is located in Fivetonic, where the experiment is designed, launched, and we can collect the data, the metric collection. So we'll explain that a little bit later. So now if I focus more on the experiment environment that we are deploying in France. So again, we have the portal on the top where we will design the experiment and we will define the KPI we want to monitor and we want to collect to analyze. After that, we have the interworking layer where we, in that case, have a driver that aim at orchestrating the site facility, the French site facility. And in our case, we first propose to deploy the service at Bicom. So Bicom is composed of two sites, but they are viewed, so it is 2 different locations. So Bicom Rennes and the other one in Bicom Lannion. So they are around 200 kilometers far together, each other, one from this other. And but they are viewed as a single site in IP address point of view. So this is it can be seen as a single one. So we propose first to deploy the video server at Orange Châtillon, but we can deploy it where we want, for instance. We plan also to deploy the control network, the core part of the network at Bicom Rennes, especially for the control plane. And the data plane is directly implemented in Lannion, very close to the radio part, where we can transmit the content, the video content, to the user equipment. And the objective is that the user can see the virtual visit of Saint-Malo that can be seen in the virtual glasses. So the WEF, the Wireless Edge Factory, is the core part of the network infrastructure, and it is important to mention that it has been provided by Beacon. So this is our main setup. So just to have a look on the different equipment that we put in place in this infrastructure. So on the top, on the left, we have the 5G Eve servers that are located in Châtillon, where we can have the ONAP orchestration. We have also the different VNF that are hosted in this server. And we have also implemented what we call the Kafka broker. So the Kafka broker is the tool that where the KPI are collected and that should be pushed to the portal. And the objective is to have one Kafka broker for the overall French site facility in order to have a single interface with the portal, and also to ensure the connectivity with the other side. So on the left, we can see the RAN part, so with the antenna, the LOH, and the BBU that are hosted in the rack. And very close to this rack, we have the cloud OpenStack hosting the data plane core network here. And so this is a very compact boxes where the radio part is directly connected. And we can launch the experiment and receive it at the mobile phone here on the right, where this mobile phone is directly connected to the end-mounted display. And we have several screens where we can monitor the experiment with the KPIs that we can measure, and also the scene that is we can see the right and left eye of the scene that is that can be viewed also in the end-mounted display. So we reconstruct the scene with the two eyes. So now I let the floor to my colleague Sofiane, who will explain us the way we manage the connectivity with the different sites and how we can monitor the connectivity between them. Yes, please, Sofiane, if you can share.
Thank you, Rodolphe. You should be seeing my screen right now. And I wanted to welcome you all to our webinar again. And I'll be talking about the infrastructure side, what we have put in place in the French side, explain the metrics and how it would affect the use cases running above this French side. We will also see what tools we put in place, actually built and put in place in order to monitor this French site and ensure that each time someone who's willing to experiment using our French site will have the infrastructure available to perform these tests. So, first of all, the French site is composed of 3 partners, 4 if you count if we count ourselves as the central orchestration layer of this site. We also have another interconnection, as explained by Rodolphe, since our clients, let's say infrastructure clients, are coming from the portal at any time of the day. They should connect through the portal, arrive at our infrastructure, run the experiment. This is the workflow. So in order to do that, we are, of course, interconnected with the Italian site, which represents here the interworking layer that welcomes those requests from the experimenters, transfers them to the French node if requested so. By the way, this experiment will be done later on by Elian and Anne, and you will be seeing all what I'm describing in action. So in order to do that, what we have done is ensure connectivity with the Italian site, which we monitor all day through automation, through automated tools. You can see that the latency is around 50 milliseconds. Some of you will wonder, is 50 milliseconds enough? The answer to which is yes, because this layer is only used when the deployment request is made to the orchestration layer. So it's not going to be, let's say, used for real-time traffic. That kind of traffic will be only local to the French node. This layer is used, as I said, to the orchestration and also to the feedback loop, which concerns the monitoring phase. So this is about the Italian link. The other partners in France are in order: Nokia, Euricom, and Beacom. The last of which we are going to see in detail, but the first two are, as you see, in terms of latency, much shorter in terms of latency, which allows us to run experiments at least 4G capable, and then later on 5G, as Rodolphe said earlier. So in order to monitor this infrastructure and ensure that it is available to experimenters at all time, what we have done is build and deploy a tool based on iperf, which is an open source tool, in combination with another open source tool, which is Prometheus. And Prometheus is a time series database which will get the results from exporters. Exporters are the ones that are running iperf tests, right? So we have probes installed in each of the sites that I mentioned before. Each of the 4 that you see on the screen, the Italian site, the Nokia, Euricom, and Beacom site, the iperf exporter in the French node installed in the orchestration layer at Orange is going to probe the nodes located in France or in Italy at different times of the day. It's going to gather the data from these tests, from this probing, and show them in the Prometheus database. This is how we do our, let's say, monitoring of the site and ensure that it is up at all time. So you can see at the right-hand side an excerpt from this configuration, only a small relevant part to which I was referring earlier. So at the end, you can see also that we have put in place a Kafka node that will be emphasized and explained later on by my colleagues. So I'll let that only here as an indication. Next, what you can see here is the targets. So the targets, this is, by the way, the menu that you get when you go through the Prometheus window, right? So if you go to the dashboard of Prometheus, of course, you can export the data from Prometheus to show them in other tools, such as Grafana or something else. That is up to you. For us, it was enough to have just Prometheus as a dashboard. So once you get to that dashboard, you see the targets, of course, which represent the iperf probes of this monitoring site that we have put in place, monitoring solution that we have put in place. You can see that all the probes are up, or at least were up at the time of recording of this, of course, this screenshot. And of course, the procedure is as simple as contacting our colleagues, our trusted partners in the French node. If any of the states goes down, we have plenty of communication tools to reach them, and they react very quickly to solve the issue, if any. So I promised you we are going to detail the Beacom node. So this is what we do now, and as you see, Beacom is, for the sake of illustration, we have chosen this node because this is the node where we have deployed the core network that serves this experiment that we are showing you today, right? So it is relevant to understand in terms of infrastructure what that entails. So if you take the Beacom node as seen from the orchestration layer in Paris, the latency we have seen before is around 5 milliseconds or 10, if I remember correctly. So so now what is relevant to see is the throughput, and the throughput through iperf done with only one TCP flow, right? Only one TCP flow is around 420 megabits per second. This not counting the control plane for the iperf test, which puts it up to around 500 megabits per second. So this is only for one TCP flow. We have made extensive tests with this node in UDP and TCP, which demonstrated that the actual throughput is around 1 gigabits per second of traffic. Again, that we monitor through the tools and make sure that it is available all day. So in order to take advantage from this infrastructure that we put forward to our experimenters, that we monitor all day and ensure it is available, what I'm going to do is give the hand to Anne without further ado, in order to for her to explain to us how we designed the experiment, how we measure the metrics, and show us later on with Ilian how to do so. So Anne, take it away.
It's okay, Anne, we can see.
So we are on the test execution and monitoring phase, where a user can launch an experiment on the 360 video streaming use case and visualize monitoring graph. The key components involved in this experiment are a 360 video server based on A-frame and Dash.js, where experiment script and Node.js server are embedded. This Node.js server is in charge of collecting metrics and sent it to a Kafka broker. We use an open source run and core components, 4G network infrastructure, and infrastructure metric provided by a daemonic probe, the downlink user data rate, and service metric collection provided by a software, Dash.js and Node.js server, and sent to the Kafka broker. Concerning the 360 video streaming path, the user, which is located in Lannion, use a head-mounted display connected to a PC, where Firefox is used to launch the 360 video streaming and enter to the VR. The 360 content is streamed from a video server located in Orange Châtillon through a 4G infrastructure. And concerning the experiment service metric collection path, the experiment is launched on the video server VNF using the portal located in 5 Tonic via the interworking layer, which is located in Turin. Service metrics from the Dash player on the user terminal and those from the video server are collected by the Node.js server, which is on the video server VNF. And these metrics are sent to a Kafka broker, which is located in Orange Châtillon, in order to be graphed on the portal and sent to the user terminal to be played to. There are 5 components involved in the service metric collection. The HTML page launched on the user terminal, which is connected via socket.io to the Node.js server, which is on the 360 video server VNF. The Node.js server is in charge of listening the HTML page socket.io message, which are the Dash.js player metrics, and sent it to Kafka, to a Kafka broker on metric specific topic using Kafka Node Producer. It's also in charge of collecting some metrics on the video server and sending to the Kafka broker and to the HTML page via socket.io. The Kafka broker is in charge of managing metric specific topic, and the interworking layer is the Kafka consumer in charge of retrieving metrics from the specific metrics topic and send it to the portal in order to graph them. The portal allowing to launch the experiment on the video server VNF and graph metrics. There are 4 metrics which are sent to the Kafka broker every second. 3 of them are collected in the video server. The end-to-end latency, which is the latency between the end user and the video server. This is the socket-EU latency, in fact. The video server throughput measured with dstat on the egress interface of the video server. The add delay needed in one of the experiments and measured with a ping from the egress interface of the video server to its gateway. And one is collected on the video dash player on the user terminal. And this is the video buffer level, which is 30 seconds for video streaming in good condition. We have also 5 other dash video player metrics, which are collected and displayed on the user terminal. And we have 2 main experiments. One where the latency is added on the egress interface of the video server and monitored by the add delay metrics. And the second one where the download bandwidth is limited on the egress interface of the video server and monitored by the throughput metrics. In the demo, the bandwidth needed for the video is 9 megabytes per second, and the bandwidth limitation will be applied from 6 megabits per second for during 20 seconds, then 4 megabits per second during also 20 seconds, and 2 megabits per second for 20 seconds too, then no limitation. And we will see the impact of this bandwidth limitation on the buffer level metrics. More the bandwidth is limited, more the buffer level decrease, and when its value is under 2 seconds, the 360 video will freeze.
Okay, so thank you, Anne. Now I will give the floor to Gregor, who will present us ONAP and the deployment of the web company.
Okay, thank you, Rudolf. Thank you, Sofan. Thank you, Anne, for the introduction. If you just could confirm if you can see my presentation.
It's okay, Gregor. You can continue.
Perfect. So, in this part, I'm going to tell a few words about the management and orchestration technology, about the ONAP solution, and at the end, I'm going to show the demo we orchestrated with our core network on a virtualized infrastructure. So, first of all, we have to notice, we have to realize that the 5G platform is not only a simple placeholder for the 5G use cases. 5G platform is much because it's empowered by nanotechnology. One of the major objectives of 5G platform is to push forward, develop management and orchestration technology. Management and orchestration standard that has been developed by ETSI is one of the key enablers for the 5G networks. Potential that we can notice nowadays that from the physical network function into the network function allows us to fully control virtual network functions deployed on the virtualized infrastructure. In 5G platform, we have developed a hierarchical orchestration stack. On our screens, we can see a simplified architecture of 5G platform. So let's focus first at the lower part of the architecture. At the bottom, we can see 4 blue blocks. Each of them is a separated test beds. Each of them contains local orchestrators that manages virtualized infrastructure inside this test bed. What's more, we can notice as well that each local orchestrator is somehow connected to the bigger yellow block, what we called in our project interworking layer, or just a global orchestrator. So the main goal of this block is to translate the request coming from the portal, coming from the verticals, and pass the orchestration and management instruction to the proper local orchestrator. So we have 2 levels of the orchestrators, a global one and ones inside each site facility. In our project, we utilize 2 main Mano tools, Open Network Automation Platform, ONAP, and open source Mano OSN. Both projects, both solutions, both tools are open source projects that are the most promising implementation that allows to manage the whole virtualized network. So now I will pass my voice to my colleague Michał to explain. As a French, I decided to utilize the ONAP technology.
Yeah, thank you, Grzegorz. I would shortly introduce ONAP platform, which, as Grzegorz said, is used as French site orchestrator. So ONAP is an open source platform that allows for orchestration, management, and automation of network services. It enables lifecycle management. What, Grzegorz, could you show the presentation? It enables lifecycle management, what is a key requirement for 5G networks. ONAP is being developed by Linux Foundation since 2017. It was formed from combining eComp and OpenO projects. In June 2020, the 6th ONAP version called Frankfurt has been released. ONAP supports several virtualization platforms such as Kubernetes, OpenStack, and OpenShift, so it allows to orchestrate VNFs, CNFs, and PNFs. Orange is very involved in this project, which made Orange the 3rd contributor to ONAP platform according to Bitergia Analytics tools. Next slide, please. On this slide, we can see the ONAP architecture that provides 2 frameworks which enable to split design and creation phase from the deployment phase. The main component of the design time framework is software design and creation tool called SDC. Network services are represented as forwarding graphs composed of multiple VNFs. The service model is stored in SDC, while other components are notified about each service. In the video prepared to this demo, we can see the dashboard of the SDC application. Virtual infrastructure service orchestrator is a key component of runtime framework, which communicates with other components and coordinates the deployment process. In order to deploy the service, a set of steps and actions called building blocks are performed. Virtual infrastructure deployment enables selection of the services and triggers the instantiation process in Service Orchestrator. Multi-cloud is responsible for collecting information about tenants and cloud registered into ONAP. ONAP supports lifecycle management thanks to policy framework and closed-loop automation components. Reconfiguration operations are performed using application controller. Moreover, ONAP exposes a set of APIs which enables third-party application to communicate and utilize functionalities offered by ONAP. Thank you, Grzegorz. Let's continue.
Okay, so thank you, Michał. So now I'm going to tell more about how the orchestration works in more detailed way in our project, and basically to explain what our demonstration is going to present, is going to contain. So the whole process of the orchestration starts at the portal level. Once the vertical comes to the portal and select the proper use case they want to play with, our experiment lifecycle manager is just passing the request to interworking layer, especially to the multi-service network orchestrator, which is in fact our global orchestrator. Multi-network site orchestrator is passing this request through the ONAP driver to the ONAP instance located in the Paris in Châtillon. ONAP just purely handles this request and deploys the VNFs, deploys core network on a proper VM, on a proper virtual infrastructure manager. This time in our demonstration, it will be an OpenStack instance of Beacon located in the RANs. As not each of the components in the 5G framework has been validated yet, so we have to limitate our demonstration to start the orchestration flow from the level of the interworking layer, from the level of the multi-site network orchestrator. So in a moment, I'm going to send a HTTP post request that will mimic the behavior of the global orchestrator of the multi-site network orchestrator to orchestrate with our core network. This request, just note, this request goes through the ONAP driver. This is an additional element that we have developed for the usage of the 5G platform to make ONAP a northbound interface compliant with the ETSI SOL 005 standard. Because the multi-site network orchestrator as well as OSM is working in a fully compatible mode to the ETSI communication standard. So we have as well decided to develop the additional element that that allows us to integrate with the our global orchestrator. What's more, ONAP driver allows us to make orchestration process fully automated. In normal mode, orchestration process in ONAP consists of sending about 50 HTTP requests, but using the automation SDK that is built in we have limited this procedure just to sending 2 HTTP requests, exactly what is described in the SOL 005 standard. So this request will be sent from the multi-site network orchestrator through the ONAP driver to the ONAP instance. ONAP will handle this request and just ask to deploy the VNFs, to deploy the web, deploy our core network on the OpenStack instance of the Beacon. Okay, so let me now switch to the video. Just if you could confirm that you can see my video on your screen.
Okay, Gregor, we can see.
Okay. So let's start to log into the ONAP dashboard, to the ONAP portal as a designer user. We just wanted to present you that the templates, the heat templates that ONAP is consuming, and thanks to these templates, we are able to deploy any VNFs. This is some kind of the templates description of the service has been already uploaded to the ONAP Service Design Creation Studio. It's a manually step done only once at the beginning when we introduce new use case to the 5G platform. It's done by the site manager, by the role of the site manager. Yeah, we can see that the web descriptor is already onboarded, pre-onboarded by the site manager. So we can go to the interworking layer, and from this level, from the level of multi-site network orchestrator, to send the HTTP post request to create a web control plane. It's done in 2 steps, as I mentioned. The first step is to create a network service instance identifier. Yeah, it's already created. We are just copy paste it into the next post HTTP request just to instantiate a network instance. You can see it's almost live. How quick is this process? We can just refresh the stack page on the OpenStack. New stack has appeared, and it will take 3-4 seconds just to deploy all the control plane of web solution on the OpenStack. Yeah, and voila, that's it. We have our control plane already deployed on the OpenStack. Now we are going to one of the dashboard on the web just to confirm that we are able to access it. Yeah, and it is. We have our control plane network already deployed on the OpenStack. We can now transmit the video 360 throughout this network. So in the same way, we are going now to present you how we are able just in one shot, let's say, delete, remove this service, remove the whole network from the OpenStack. It's done in the same 2 steps mode. In first step, we are terminate the service, stop the service, and in the second step, we are removal it from the OpenStack. Yeah, let's see what's happened on the OpenStack. We can see the delete in progress. We can see that the virtual machines are under destruction. It takes a few seconds, and voila, it is almost everything disappeared. And we can just ask from the interworking layer, from the global orchestrator about this service, and as we can see, ONAP just returned that this service is not exist anymore. It's not found. So
okay, so thank you, Gregor.
Okay, so just the short summary. I want to say two words more. That we in today's demo we have presented the very basic, the lifecycle management operation, only a creation of the instance and the removal of it. But the 5G platform contains much more functionalities, much more features, and that as well was implemented. For example, I can note that we have developed the notification and subscribe system for the monitoring of the status of the network services. So I hope for the next webinar we could present the orchestration possibilities that we developed thanks to the ONAP. Yeah, thank you.
Okay, so thank you, Gregor, for this nice presentation. So now I propose to move to the next part about the service design. So I'll let the floor to Eliane, explaining us how we can now design our experiment and to collect the KPIs that we want to monitor with the experimentation we are planning. So Eliane, please. I can't hear you. You are in mute mode, Eliane, I think.
Sorry, yes, I was in mute mode. Do you see my screen, right?
Yeah, it's okay, we can see.
Okay, hello everyone, I'm Eliane Kraja from Nextworks. We are going now to follow the steps necessary on the dashboard part, on the GUI of the 5G portal, from the onboarding of an experiment to the execution of it. I'm logging as an experiment designer user in this moment to the dashboard. I will be able to onboard the vertical service blueprint, which will be the first one when the dashboard will be ready, and the test case blueprint for this experiment, and then we will follow with the experiment itself. Let's start. We will focus on the green button here, the design experiment. As a first step, we will go for the uploading of the definition of the blueprint. The file is a JSON file, which is hopefully I'm able to show it in here. There is the definition contains basically the atomic components, which are the components of the service. In this case, we have 2 of them. The application metrics that are published by the function itself, and the compatible sites, which is a list of sites where it is possible to deploy the experiment. Since the deployment of the NSDs on the ONAP was done manually, we will go for a static deployment. So the dashboard in this case will not trigger the onboarding of the NSDs. We have now, as you can see, the experiment showing with our 2 components, the video server and the WEF, which is the core component of the RAN, where basically the user is connected. Now we can move to the test case blueprint, which is the main execution of the experiment. It contains and starts basically the scripts that are run for the real execution. There are 2 different ways to upload it, via JSON file or just compiling the wizard on the GUI. We will go for the JSON one. We are going to run the bandwidth limitation test case, which was explained by Anne during her presentation. As you can see, the new test case blueprint is uploaded. Basically, we will perform some actions. The configuration part will configure the VM in order to send the metrics to the proper Kafka broker, and the execution part, where basically it's the real execution, where the server is acting as the video is running. After the test case blueprint, we need to create the experiment blueprint. In this case, we need to compile this wizard. As I already said, we are going for a static deployment. In this case, we select the vertical service blueprint related to the experiment we want to run and the site when we want it to run. We choose REN because was the only compatible site for this experiment, and the proper vertical service blueprint. We don't have context blueprint for this experiment, so we just click on the no context blueprint. In this part, we can add the infrastructure metrics we want to measure. In our experiment, there is none, but we have a KPI that will be calculated, which is the threshold that I was showing before in the vertical service blueprint. In the formula, we are just saying to the RAF component, which is the validator of the KPI, how to calculate the KPI. In this case, we have a straightforward, basically, formula. So KPI equals throughput. will be calculated in kilobits per second, each 10 milliseconds. The graph will be linear, so a line, and the metrics involved are just throughput. And on the last tab, we have to add our test case blueprint, which contains the execution part, which is the last one we added a few seconds before. As you can see, the experiment blueprint is ready. Is the last one, this one. Let's just go through it. So it will run in ren. The KPI is the throughput KPI. By this, the experiment developer has finished working on the design experiment and now needs to create the experiment for the execution. As a first step, need to create the experiment descriptor, which basically is providing some of the answers to the blueprint, to the parameters of the various blueprints we use. We go by choosing the experiment we want to run. We give a name. A vertical service descriptor will be also associated to the experiment descriptor. We will provide some slice parameters in this case, and the lower bound and upper bound for the KPI. We will stay with 0 on the lower bound and 20K, 20,000 basically on the upper bound. We have no context, so we have no parameters to put in there, and now we need some values for the parameters for the test case, which are the username to access the web server VNF, the password, and the IP address. We need the IP address because actually we're deploying it statically, so the MSNO is not able to get the IP address. Instead of static deployment, if we were running a normal deployment, in that case this was not a parameter requested to the user, but it should be infrastructure parameter that is basically triggered, and the system will get it directly automatically from the MSNO, so no request to the user. We have our experiment descriptor. Now we need to request a new experiment. By this, the site manager of the infrastructure where the experiment is requested will receive a notification email and will need to allow us to run the experiment. I'm choosing the target site way to run it, the use case, and the range for the timing from today to, let's say, 11th. As you can see now, the experiment is on a scheduling status. The site manager has received an email notifying him that there is a new experiment waiting for approval.
I confirm, Eliane, I received this email. So
Yeah.
accept the experiment.
Yes, thank you.
So I have accepted.
So now the experiment is accepted, but still the experimenter cannot do anything on it until the infrastructure is ready, and when the infrastructure is ready to accept this experiment, the site manager should change the status to ready for this experiment, which Rodolphe should be doing now.
I change it. It's okay.
Thank you.
You can run the experiment.
So now the experiment is ready, and the experimenters is able to run the experiment. So first of all, we need to deploy it. In this case, as I said, the MSNO will not be triggered because the NSDs are statically deployed on the ONAP side, but all the other components of the 5G infrastructure will be triggered and ready to accept the experiment. Once the status of the experiment is in instantiated state, we are able to run the experiment, to run the execution of the experiment. Only in this case, we will be able then to show the data, to see the data from the video server with the metrics of the throughput that we are expecting. During this phase, there are different phases. In this case, the configuration was immediately, but there is a configuration state where, as I said, the VNFs are configured. Then there is the running of the experiment, where basically we run the real experiment. So we will show some data on the dashboard once the metrics are ready. It takes more or less 2-3 minutes for the experiment to run. Now the first dashboard is showing, is the throughput dashboard. As you can see, it started with 6 megabits per second traffic. Now we are facing the first limitation to 4. I will move back and reopen the dashboard in order to see the other 2 decreases due to this limitation. Yeah, as you can see, the 4 megabits limitation and the 2 megabits limitation, and from this point on there is no more limitation, so the graphic will grow up normally to the proper values. Now the experiment should be executed. The status has changed, so we can see that the run has completed with a positive result, and we can show the result of the RAV, which is the resultant analysis validation, showing our KPIs calculated through the data received from the VNF. As you can see here, we have the limitation of 6, then 4, then 2 that Anne was mentioning. With this, the experiment is ready to be terminated, and that's all from my presentation.
Okay, thank you, Ian, for this nice presentation. So now I will move to the video that will show what happened in the Lannion site, where the video can be viewed. So I will share my screen too. Okay, can you confirm you can see my screen?
Yes, Rodolphe will see it.
So I launched the what has been viewed at the Lannion site. So you can see Anne watching on the Edmonton display the virtual scene. So at the lab, we can monitor also some KPI. So when Eliane launched the experiment from the portal, we have to open the HTML page in order to view the virtual reality scene. So as we will see. And we will see that we are launching the experiment as mentioned by Anne with the bandwidth limitation. So we can also monitor at the lab some specific information. So I just put in pause mode. So on the left side on the monitor, we can see some specific KPI, metric KPIs that we can collect. For instance, we mentioned that the number of frames per second is 60. So the encoding of the video is at 9 megabits per second. And we have also some information as the number of frames that are dropped during the transmission. This is on the left side. So on the right side, we can see, as mentioned, we'll see the different level of throughput at the output of the video server. So as 6 megabits, so 4 and 2. And then we will see that we relax the bandwidth limitation and we will increase the throughput as the same manner. We can see one important information concerning the buffer level occupancy. So this is the memory of video, the video memory that we can have on the buffers in order to have advanced video content in the web page. So more the throughput is, more the buffer level will be. And in that case, we will see that at the end of the experiment, when the throughput will go to 20 megabits, we will have a high increase of this buffer level. We have also different screens that could be that can visualize the execution of the experiment. So, for instance, here we can see that the KPI are received from the Kafka broker located in Châtillon. And on the white screen, we have the metric, the infrastructure KPI that we can measure at the radio part. So especially we can see that we have at this moment, for instance, more than 12 megabits per second of transmission. And of course, when decreasing the bandwidth limitation of the video, we will see that the radio limit also the throughput. So we have different kind of network KPIs that can be monitored also. And the objective is next to be able to collect also this information directly at the portal level. So you will just see at the end that yes, at this moment the throughput is increasing, and the buffer level is increasing too. So as Anne mentioned, when we are less than 2 seconds of buffer level, the video freeze. And so we can't see at this moment, but when we have some people moving in the street, they are sometimes fixed. So this is this kind of information that we need to know in order to qualify the services. And we have also some perspective of improving this experiment. So I will just, to finish, conclude my talk. So I will share the conclusion. Okay, so just to conclude, I will put in presentation mode. Oops. Okay, so just to conclude, sorry. Oh, sorry, not a good one. Oops. I don't know why. So sorry, just one moment. Oh, sorry. Stop sharing. Okay, so just to, I will make the conclusion by in oral mode. So just to mention that we succeeded first to make our experimentation in such facilities. The first experiment that we have in end-to-end mode. So thank you, Sophia. Gregor. So we have presented the French side facility and the 360 video service first. So we have also show you the way how we can supervise and how we can monitor the network infrastructure connectivity between the different French sites, but also with the interworking layer. So we have presented the deployment of VNF, especially from infrastructure networks, with the WEF, the core part of the infrastructure. So for that, we are using ONAP. So what we can mention now is that we succeed to deploy some VNF from Orange to Beacom and to Nokia. And it will be available soon also with Eurecom. The main difference with Eurecom is that Eurecom is using OpenShift instead of OpenStack. And in that case, we have to adapt a little bit our ONAP in order to be able to deploy some CNF and PNF on this on their VM. Also, we have yes, you have integrated the 360 video use case in our facility in the static mode, as already mentioned. And the next step will be to be able to deploy dynamically the different VNF in order to have an end-to-end automated setup for this experiment. We have also show you we have presented the service KPI collection and the visualization at the portal level. So we have mentioning that we be able to monitor the throughput, but now it should be possible also to collect all the other service metrics that we are planning as the delay and also as the number of the number of frames that are blew up and so on, and also the buffer occupancy. So I think the buffer level occupancy is also very important and interesting for our use case. And also we are planning to be able to monitor network infrastructure KPI, especially at the radio and at the core part. Now, as we can see, it's time also to upgrade the site facility with 5G. So we are using first 4G. It is the basis for our comparison with 5G. But in the next step and in very next months, we will be able to compare this performance with in 5G infrastructure, especially by using the Nokia and the Eurecom ones that are mainly based on 5G, and also Beacom that will be upgrade in 5G infrastructure component. And also what we plan to do is to deploy this service in a real environment. So as I mentioned, maybe in outdoor, it should be possible to improve this experiment by having this virtual visit in a place and in outdoor place, for instance. And also to be able to increase the capacity of the network by putting more than one user in the experiment, and to be able to monitor several users, because as we can mention is that more the user, more the data throughput will be, and in that case, it would be important to show the limit of using 5G with a number of users that are put in the real environment. So that's all. I would like to thank you for again for attending this webinar. So also thank you for all the participants and all the presenters. And if you have any questions, so please, time is yours. So I will check the chat if you have some question on the chat. But please, if you have any question, please, we are ready to answer. So I don't see any question on the chat. Maybe on the online.
Can you hear me?
Yeah, I can hear you. Yeah.
Oh, yeah, this is Darek. Well, perhaps this is a question by colleagues from Poland, but maybe to other also. Regarding WEF and your orchestration in this domain, have you experienced anything with reconfiguring WEF in runtime, let's say, or orchestrating WEF somehow, changing some parameters or something, or just it's deployed service running and then not touched in a sense during the runtime, apart from killing as Grzegorz provided?
Yeah, thank you, Derek, for this question. So honestly speaking, one of the component of interworking layer called the runtime configurator is the key component that is dedicated for the reconfiguration of the VNF reconfiguration of the services. It's not yet integrated with the ONAP, but we consider to integrate it. What's more, we are as well considering some other solutions, like using a Flexrun configurator to perform any changes, any modifications on the run part. But it's a matter of the future and a matter of the next year. So for the current status, not yet. The lifecycle management operations are not in the charge, not implemented in our project, but we are considering to do it in the next year. As for now, we have prepared the notification and subscriptions methods. It allows us to monitor the status of the network service.
Oh, fine. Okay. Thanks. Okay, thank you. It's
okay.
Enough for me.
No other question. Yes, you have a question in the chat. Maybe it's also for you, Gregor. So the question is, may I ask if you have considered an option of cloud native principle for verticals, allowing them to have their services orchestrated via ONAP without the need to understand it or telco-related concept and terminology?
Yes, exactly. That's the key concept of the 5G platform, I think, to make it really useful and easy. Let's say how to call it. Very yeah, just name it, easy to use. We don't have to understand the HIT terminology. We don't need to understand the telco-related concept and terminology. And the user that comes to the 5G platform have to only select the proper use case that they want to play with and just click on the, let's say, deploy button, and all the workflow will be done automatically. Today, as I mentioned, not each of the 5G platform components are validated and integrated yet, so we have separated our demonstration. It was demonstration done on the portal level. It was demonstration done on the interworking layer and ONAP level. But at the end of the project, in 1 year, we are going to achieve a milestone to make it fully automated. So the end user of this platform should only know where to click the deploy button, and all the orchestration flow will be done automatically. I'm not sure if I answer your question directly, but okay, thank you.
Okay, so and the question is, will this be sent back to ONAP as a contribution? This is a question also for
yeah. This is a very good question. We are considering as well to deploy to contribute with partially with our development to the ONAP community. we can see, honestly speaking, the one new contribution that we can make based on the 5G platform is just to push our code, our ONAP driver to the ONAP community. It's maybe not directly inside the ONAP, but it may be some kind of the client to the ONAP, the client, external client that will trigger some actions, some operations on the ONAP. So yes, we are considering the pushing our code to the ONAP community, but only as a, let's say, external client, not directly into the ONAP itself, because ONAP itself is developed by another our colleagues that we are cooperating with in Orange, Poland, and some contribution as an external client is considering to be pushed to the community.
Okay, so thank you. Any other question or any part of the presentation of the webinar? So if not, thanks again for your participation, and so I wish you a very nice evening. And again, we will share the link of the video if you want to see it again. Okay, thank you very much. Have a nice evening. Bye-bye.